Hello, everyone, and welcome to another Jakarta Tech Talk. My name is Serena, and joining us today is Otavio and Dario, who will be presenting on the topic of unlocking powers of Eclipse JNoSQL 1.1.0 with Oracle NoSQL. If you have any questions for Octavio Dario during today's presentation, feel free to ask them in the chat or use the Ask a Questions tab. Without any further delay, Octavio, Dario, over to you.
Okay, nice. Hello, everyone. Super glad to be here. I am with Dario, who is a amazing person right now. He lives in Paris, right, Dario?
Yes,
And
exactly.
and we're gonna cover a little bit more about what is NoSQL database, how to use it, is it something to eat? Maybe, perhaps, who knows? And explain how to make your life easier in enterprise architecture with Oracle NoSQL. Okay, so I will share my screen. Let me share 1 second. No, share screen. So as Serena said, hopefully the audio will be okay today. If you're not able to hear us, please let us know. But as I said, so the goal today is to talk more about NoSQL and with Oracle NoSQL. And naturally, I need to explain. Okay, both have NoSQL in the name, right? Oracle NoSQL and Eclipse JNoSQL. But Otavio, I do have a question about that because what is NoSQL database? We have mentioned that a lot, but I'm super familiar with relation database. Oh, so briefly, yes, we do have NoSQL database. We do have relation database. Relation database is amazing. It's not deprecated at all. NoSQL database is just a new flavor of persistence that you can enjoy, use, and express your enterprise architecture. So um, we do have several approaches or several types of NoSQL database. We don't have standards in NoSQL database like we do have with relational database. Okay. Here, I will cover only four NoSQL database types. However, we have much more types. And the type is defined by the way that we store that information on my computer, my server, my whatever. So let's cover one by one. And also a good point to worth to highlight is that today we do have over 200 NoSQL database. Yes, it's a huge amount of that. It's like crazy. Covering those NoSQL database today, I will cover only four of the most popular ones. The first one that we've talked more is the key value. The key value has a super simple structure where I do have a key, and to this key, I can retrieve information based on that key, and that is it. So I have a huge blob of information that I'm capable to return based on that key. If I want to search by something else, I'm not able to because as I said, key value is like the map on Java. You're not capable to do something else unless you get the key, return the whole information, and then go do the linear search one by one. There's no optimization on it. Then we do have the wide column or column family. It's pretty similar. So mostly of the time you're gonna search by the key. However, with this one here, instead of search by a huge blob, you can take a small piece of information provided by columns. So that's why column family, right? So we put a couple information in small piece columns, and that is it. Then there is a document type that has a structure pretty similar to a document JSON or XML JSON. This one here has more rich capabilities of queries, searchings, and so on. For example, I can do more easily the search to something else than the ID. Furthermore, I can aggregate, I can combine, I can do more capabilities, pretty similar to relational database. And the last one that we covered today is, of course, the graph database that you can do even deep relationship than the relational database. For example, with relational database, I can do the one-to-one, one-to-any, and one-to-any relationships, but we don't have directions. We don't have properties on that relationship. And guess what? You can do everything with this graph database. Yes, properties, directions, and so on. So it's super amazing to have these kind of capabilities inside a NoSQL database. And there's, as I said, there are more types. For example, there is time series where you query you be more basically more around the time, of course. There is the multi-value. The multi-value is not a type itself, is more a concept. When a NoSQL database has support to more than one type, we call that multi-value database. This way, for example, AronDB has support to more than one type, key value, document, and graph. This way, it is AronDB is a multi-value type, so it has support to multiple types. Oracle NoSQL right now has support to key value and document. This way, Oracle NoSQL is also a multi-value database on NoSQL category, of course. And okay, I mentioned the rich capability of NoSQL database. As I mentioned, we don't have a standard yet. We have the category by the way that structure information inside our server, the way that stores that information. We do have over 200 NoSQL database. That's a huge amount. And okay, Otavio, let's move on to use that with Java, right? Because we are developers, want to write some integration with NoSQL database and so on. And how to do that? How to achieve that success using Java with NoSQL database? Right now, also, we don't have standards to each NoSQL database. I need to learn a new classes, a new methodology, terminology, and so on. Take here, for example, we do have four different NoSQL databases: AronDB, MongoDB, Couchbase, or NTB. Those are four document NoSQL types, as you can see here. We are trying to achieve the same result. So I have the name of the document and the information itself. So the name is a name variable, the value or the information, the value information. And then, as you can see, everybody is doing exactly something, inserting a document, but with different terminology, classes, way to instantiate it, and so on. So around DB, I'm using base document and then add attribute. Document, I'm doing the document append, old document to ORNDB with field, JSON object with put, and so on. So everybody with the same goal, but totally different the way to achieve that. And it happened with the majority of NoSQL database types. So I mentioned document, but it also does with key value. So as you can see here, I have four different NoSQL databases of the type key value: Redis, React, InfiniSpan, and Oracle NoSQL. Everybody is working to achieve the same results and the same success to insert information on the database. And as you can see here, the key, the red one, the value is the blue one, and everybody is using different class, different name, different methodology, and so on. And of course, it is not good to cognitive load for us, Java developer. It's super heavy to, okay, I need to learn a new API, I need to achieve, read the documentation and so on. We should need to learn about the NoSQL database that we're gonna use, of course, but why do I need to learn a new API if I'm trying to do exactly something? And that is the main goal of Eclipse JNoSQL itself. It is the main goal of, for example, the Jakarta NoSQL specification to make easier to us to using the same API we're gonna be capable to do NoSQL interactions. For example, take here, for example, we do have my document entity, I do have my collection, and based on this interface, I can interact with OrientDB, ArongDB, MongoDB, Couchbase, and so on. And the good point here is I don't need to get pressure on that. I don't need to go deep on that. So basically, based on this, I'm super fine. I don't. I mean, on this document here, document entity, I don't need to know where I'm gonna insert that information. Okay, and that's why we do have Eclipse JNoSQL. JNoSQL stands for Java NoSQL database, of course. And right now we have support for four different types. So column family or white column, graph, document, and key value. And of course, as Java developer, I do have my entity. I will put several annotations and make this magic happen for us. So for example, I do have my Pokemon here. So ID, column, and location. We do have support to record, as you can see, to define my entity, to define my class as one thing that I want to insert in my database. I put the entity annotation to define the ID annotation. It should define any field that will go to the database. I put column, okay, and that is it. So the templates, the operation, and then I can do the insert, update, delete, and so on. So, and of course, with relation database, we don't usually match the particular behavior. However, when talk about NoSQL database, those are super crucial ones. I mean, the particular behavior matters a lot to us in NoSQL world. That's why we do have more extensions to work with NoSQL database. For example, take here, we do have the template that belongs to a specification, and then we do have extensions. For example, the extension of document template that is naturally an extension to work with document types. And then we do have more specializations. For example, ArongDB that is a specialization of document template that I have support to Arango query language. And then I do have MongoDB template and Couchbase template and so on. So that is the idea. And that's why we do have Jakarta NoSQL I specification itself. Move on and cover a little bit about the specification that we do have right now and the ones that we're working to release. We do have Jakarta data, for example, where the main goal is to cover more the persistence layer inside our architecture. For example, here, we do have our business layer with the whole logic, the whole everything. And then we can do have several patterns in data to make our life easier. For example, I can use repository, I can use a data access object, I can use DTO, and so on. And those do not belong specifically to a database itself. I can do active records with relational database and NoSQL database. I can do, for example, a repository with both as well, and so on. So, with naturally relational database, we do have a specialization that is Jakarta Persistent, former JPA. To NoSQL, we do have Jakarta NoSQL, and to data access layer itself, we do have the Jakarta data to handle with this kind of patterns. The first one that we're working right now is the repository. The repository comes from DDD by Eric Evans, where the main goal is to be more domain centric. And naturally, we do have several specializations like data repository, crude repository, payable repository, and so on. So right now, that is our components around Eclipse JNoSQL. So Eclipse JNoSQL use a lot of Java specifications. For example, us, a developer, will interact properly and mostly of the time with the Jakarta NoSQL specification and Jakarta data specification. And then to do any external integration, we do have JSON Bean to process JSON, CDI to the injection point and lifecycle and so on. The configuration, of course, we know that it's not good practice to put credentials inside our codes like password, username, and so on. So we can implement the 12-factor application to make our life easier and safe, and of course, avoiding any nightmare in the future. So we do have those specifications working with Jakarta NoSQL, sorry, with Eclipse NoSQL, and internally the engine does this kind of integration. For example, NoSQL are mostly annotations. Jakarta data is an interface. So we do have two layers to work and make it possible. The mapping layer will take and read the annotations and convert that to a communication layer. This way, we do have our driver that will, guess what, make our life easier being an adapter to a particular driver of any provider. So given we do have a MongoDB, we do have a driver that is an adapter to the offshore driver. And something happened, of course, with Oracle NoSQL. So NoSQL data mostly all the time are the specification that developers will looking for to interact with NoSQL database. To process JSON, we're gonna use JSON Bean, JSON Biden, sorry, CDI to dependency injection, configuration, of course, to avoid credentials, anything on the code itself, or what you can do instead is put these credentials properties locally with localhost in your file and then allow to overwriting this information or production. That's one thing that I will usually do and it's fine. At least I enjoy a lot to do it. Right now, I will cover quickly a demonstration of Jakarta NoSQL and then Dario will show more about Oracle NoSQL. Okay, so what I'm gonna show to you today is, okay, let's talk more about beers. I guess everybody enjoys, but anyway, you can use your imagination to use with wine, anything like this. So what I do have here, I do have my classic application using Halidon that is empty right now. Uh, it does the version number 4.0.5 with the properties with Eclipse JNoSQL, as you can see. I'm gonna use the data faker to generate new data. And then, as you can see, a lot of held on dependencies. So microprofile core, open API, health, JSON Bean, um, JSON binding, logging, small right to configurations, and so on. And naturally, we do have the dependency to Oracle NoSQL that will integrate with Eclipse JNoSQL. So that is what you do have here. The next step that we cover today is naturally create the entity that will be a beer. So I will create a beer. And the flow will be the same like I was doing with Jakarta persistence or JPA. So I will type down the ID. I will type down the style. I will type down the hop, the mouth, and finally I will put comments. So if you wish to put some comments inside a beer, you are most welcome to it. So by comments. So ID is style, hop, mouth, and comments. Naturally, you can do the best practice as usual. So you can overwrite uh, the equals hash codes includes the toString here as well, and done. So right now I do have my empty. The next step is naturally define my annotations. I want to define this class as a class that goes to our database. I want to define the field that will be the ID and the field that will be the one that needs to go to the database itself. So to define my beer as an entity, guess what? I will use the entity annotation. To define the ID as ID, I will use the ID annotation. And then to each field that I want to push into that database, I will put colon. So that is the main difference between JPA and Jakarta NoSQL. With Jakarta NoSQL, you must should put the annotation in each field you want to go to the database. Okay. This one here is not related to Eclipse JNoSQL itself, but with JSON Bean and JAX RS because I want to convert this class to JSON. And to make it that if doubts defining getters and setters, I will use JSON visibility and I will put my field access strategy that will um, read the information from the key instead of doing by the getters and setters. Again, it's not related to a Eclipse NoSQL itself. It's more to JAX RS because you have a REST API that will expose JSON, and we're gonna do this integration here. Then, as a next step, what I'm gonna do next is to create my repository. My repository has to go to the integration between um, my entity and my database. So I will create my BA repository. I will extend Oracle NoSQL repository BA string, where, as you can see, I have two parameters. One is my entity itself, and the second one is my ID type itself. So I will activate that using not you repository, and that is it. So right now, I do have a extension of Oracle NoSQL, as you can see here, and that extends pageable repositories. This way, I can do several operations without caring much about the implementation itself, just to make my life easier. And finally, we do have the entity, we do have the repository, and let's move on to the next stage of our presentation demo. That is, expose this API as REST. Okay, so I will create my resource. So I come here, I will define my beer resource. I will define my path. Of course, I will use a plural here. And then I define this one here as application scoped. I will inject my beer repository, beer repository. Of course, I can use only repository, doesn't matter. And then what I'm gonna do next is create this simple operation like beer, get beers, define all. So let's import here. I need to convert to list. Then I will do, oops, not you. I will do a public beer get beer. Of course, I will avoid to do that. So I'm finding by ID, it's return optional. And then what I'm gonna do, I will do or else throw, and then new web application exception that will be not found, unfortunately. Anyway, so okay, it's missing the arrow here. Sorry, my bad. So it was too much. And finally, I will just put a save here. So save that we'll put here. And finally, the last one is almost nearby this one here. So I will copy and paste, and then I will void delete and then I will do repository delete by ID. Okay, so I did the basic operation. So return everything, return by ID, save. The save a repository means if the information is there, it will update. If the information is not there, it will insert. How they people to understand that for sure, they will use the ID annotation. Right now, as a next step, I will expose a resource using the JAX RS annotation. So naturally, I want you to do a get here, the same thing here, but with different path. So this one here is the ID. I will define this one here as a path parameter. I will use put here, and I almost do the same here in delete, but of course, instead of get, I will use delete, and I will do the path parameter here as well. And then we are done. So we do have the entity with the annotations and configuration, the information that I want to put in the database. Then we do have the repository to be the bridge between the entity and the database itself. And finally, the resource to expose the whole information. So right now, what I'm gonna do, I will do a package of this and then execute my application. About the credentials, what I'm doing here, once I'm using locally, and right now, come soon, Dario will explain more how to put that in cloud, on the cloud. So I define a link post here, the host, and then I will executing because I do have a Docker application running, as you can see here, Oracle instance. Okay, so I will come here, I will clean package and then execute. While it's running, I will take my post. As you can see, I already put that information for us. So it's running. Naturally, when I do a get peer, the information, oops, no, it can be exception nonsense I produce. Okay, let's see what's going on. Probably I did something wrong, so I do have my path, I do have my get.
You are missing the inject.
Oh yes, good point. Thank you, Dario. So I was missing the inject. So right now you compile and then inject again. The injection belongs to the CDI. Anyway, it's not an excuse to forget about this small detail. Thank you to make it possible. And then, of course, we do have my beer here. Right now, I have a pail. I can insert a Brazilian malt, as you can see here. And then I have one pale malt and a Brazilian malt. I can take one here by the ID and then do the get by ID. Oops, something goes wrong. Oh yeah, I forget the E at the end. So, and so on. So that is the overview of the API. So I included dependency with Halidon, put the properties configuration, put the class, the annotation, and make the injection happen for us. So right now, I will let Dario show more about the Oracle Cloud and this amazing detail.
Okay, thank you. I'm sharing. It is okay? Yes.
Right now, you can see, yes.
Okay, perfect. So just let me take again your application. So we have the beer Java. Okay, so as you can see here, I have exactly the same application that Octavio developed during the demo. I have my beer repository, so exactly the same. I add some other, I have the possibility to find by style, and I have also the possibility to do a native query. Okay. Then we have the same resources. An interesting thing is when we are deploying using Maven archetype, you have also the Docker file and the app YAML that we need in order to deploy using Kubernetes. Okay, so I am just doing a small modification because we will use the cloud. So as you can see here, in this case, just let me do a comparison here. So previously we will say that we will use the Docker image that we have in our local host. Now I am saying that we will use the cloud. So in this case, I will connect that what we call an OCI region. And as you can see here in the deployment, I am saying that I will use the cloud and I will use a specific way to do the connection that we call instance principle. In fact, in the cloud, instead of using my API keys, or instead of using my user or create an application user, I will say that everything that is in the same, in this what we call in the same compartment, which we will in a dynamic group, and we will provide privilege to this dynamic group. So I already set up this, so I am ready to deploy my application. So the first thing that I did is I execute my Docker file in order to create my container image. So as you can see here, I am just doing the same thing that Octavio did. I am doing my Maven package, and I am copying my .jar, and then I will execute the .jar. Okay. I changed a little bit the Apple YAML in order to deploy in Kubernetes. So currently I am using an Oracle service called OKE, Oracle Kubernetes Engine. And we have some possibilities. For example, we have the possibility to have an external load balancer. And the other thing that I am just saying is I will use a private container registry that we call OCIR. And again, that is my image. I have two variables that I will change when I am doing my deployment. If you look my configuration profiles, I am saying that I will have two values, OCI region and NoSQL deployment, and I can change. For example, when I am using Kubernetes, I can use another way to do the connection that we call OKE workload identity. So in fact, we will associate the application to the namespace or to the identities that we define in Kubernetes. Okay. So I am ready. So currently, I will deploy my application in Paris. So if you go here, if we go to databases, we have multiple databases. We have MySQL, we have Postgres, we have OpenSearch, we have Redis, and of course, we have Oracle NoSQL database. So just for now, here we are able to create tables. I have another microservice called stream activity, and here we will deploy our application in this compartment that I call the Vega. And then after doing this, I will provide more explanation on what you can expect from Oracle NoSQL database in the cloud. So just let me start by deploying our application. So here I have a Kubernetes cluster. And again, currently I have a pod. That is the application, that the microservice that I shown before. And then we will deploy our application. So kubectl apply. And I will use my application YAML file. Okay. Let's see what happened. So now I have a pod with the Holy done. Okay. So if you look inside, so just let me see what are the logs. So we have the same output that Octavio has. Okay. So Just let me do some core commands in order to see what is happening. So for example, I will execute the same thing. So I will say, what are the beers that I have in my application? Oh, sorry, I need to connect. kubectl. I need to go inside for the moment. I am just testing locally. Then we can use our load balancer in order to go inside without needing to connect to the container engine. Okay. Copy. Now, currently we are creating our table because currently for Jakarta NoSQL, we decide to create everything in the, oh, what is this exception? We have the same issue. Oh, I don't know what is happening here. Oh, didn't test. Okay, so that is a good demo. I don't know what I forgot because I tested just before. So just for information, I deploy also this application in another region that we call Ashburn. Okay, and what we have is we will have our table. Remember, the name of our table is in the microconfig profiles, and we say that for this JSON document, we will have the database called Olympus. Okay, so if we go inside, in my case, I already create I add multiple beers with the content of my catalog of beers. Okay, so the interesting thing here is if I go to the application, I execute my call commands, I will have the information that I have here. And as you can see here, we have the content, the ID, we have the entity, in our case, the beer, and we have the content that we are putting in our program. Okay. So if you look, we have the information that we have in our class. Here with Octavio, we add other data like crew, like data. So we have more, that is another version of the same application, but we add more fields. Just let me show you how we did this. So if we go to demos, if we go to Oracle NoSQL source, here. In this case, as you can see here, we add a new column that we call crew. That is a list of crew. Of course, we have another entity called crew. And we have something that we call data. And here we are putting just an object with a string. It could be an enum if we prefer. And as you can see here, when we are storing, we have all the information. The crew is the name Octavio. And for data, we choose, for example, the name beer and the price of my beer. Okay, so here we don't have the same thing for the other columns. Okay? So an interesting thing is, as you can see here, everything is managed. So when you are deploying, for example, in a new region, let me go, for example, to Brazil in Sao Paulo. If you are here, you don't need to deploy any infrastructure. You just need to create a table. So at the end of the day, yes, of course, we have a cluster. We have a cluster with multiple servers, and our Oracle NoSQL database is a shared database, meaning that we will take in the key, we have, just let me go again to Ashburn, Olympus. We have the possibility to have what we call a primary key, and we have a shard. So we will use this column, so our primary key, in order to distribute the data against all the shards that we have in our cluster. Inside the cluster, we have the possibility to have a master and multiple replicas. So it means that we are replicating for high availability all the information. For example, the elected can be in a fault containment zone, and the other replicas will be in another file containment zone. When we are in the cloud, for example, and we are in Ashburn, we have multiple data centers that we call availability domains. So every time that you are inserting a data, it is replicated in multiple data centers. If we are, for example, in Ashburn, it is the case, but if we go to another thing and we don't have a multiple data center, we will have what we call fault domains. So in this case, we are replicating in all the fault domains. An interesting thing when you are working with Oracle NoSQL is you can say, okay, my application is running in Ashburn, but I want to replicate around the same application in Paris. I want to replicate the data and run the same application, for example, in Sao Paulo or in Melbourne, okay? What is the goal of here? I want to have the same REST API, but I want to have the access locally nearest to where are my customers. So in order to do, we can create what we call replicas, okay? And we can add a replica. So for example, I will choose in my case, Paris. And again, in this case for Ashburn, I am saying that I have a read capacity. So that is the number of read units that I can do per second, or the write units that I can do per second. And of course, the disk storage for this case, we have a small catalog, so we need only 1 gigabyte of storage. Of course, this information, the disk storage will be the same in all replica, but I can change my capacity because, for example, in Paris, I am expecting to have more users connecting to my database. So I just need to click here. And currently, it is a serverless service, and it is a fully managed service. So as you can see here, I don't need to set up anything in order to do this. I am not set up in a cluster in Ashburn. I am not set up in a cluster in Paris. I am not creating all that I need to do the synchronization between the two sites. I am just saying that I want to deploy the same table in Paris. In our case, you can call the same collection if you prefer, because we are using a document model. So as you can see here, after a moment, we have the initialization completeness, and now we have the same data in Paris that we have in Ashburn. Just let me execute a little bit. So as you can see here, we have the same data in Paris that we have in Ashburn. So now my application that I was running here, unfortunately, I have an issue. We will see the same data that you have in Ashburn and Paris. Okay. So just let me show that it is working. So I will modify a little bit this row in order to say that, for example, in the comments, I have a comment called Dario. And I will execute this modification in Ashburn. Now, if I go here, so now I am in Paris, and I execute the same query, we will see that we have my comment Dario, because it is an active replication, even if it is happening in a synchronous way. We have the same information in both sides, okay? I think, Octavio, that in Jakarta NoSQL, we have also the possibility to set the time to live when we are using Jakarta NoSQL. So I just want to show, even if I don't have the program, I will show how it is working. So we have the possibility to set up a default. For example, I can say, I want that every single row that I am inserting by default, it will expire after 5 seconds. After 5 days, sorry. So it means that I have the possibility in every single row to say, okay, I want to say what is my time to live for this table. So I prepare a little bit this. So we have some metadata, and I will use one of them. Order So we have a column that we call expiration time. And I will show you what is the column. So currently, when you have this value, it means that the data are not expiring, but I did just before to coming here, I update one and it will expire at 8 p.m. UTC time, okay? So the interesting thing is, if you remember, I did the modification in Ashburn. So when I am doing the replication from Ashburn to Paris, I have exactly the same value even for the expiration time. It means that when a data expires in Ashburn, it will automatically expire in Paris. And if I have, for example, in Sao Paulo, it will automatically expire also in Sao Paulo. You don't need to manage this. We are managing this for you. So that is one of the examples that I want to show you today. So just for example, here now I am in Paris and I want to replicate to Sao Paulo, okay? So I just want to say, I want to go to Sao Paulo. Oh, where is Sao Paulo? Sao Paulo. And I will reduce because I have less customer in Sao Paulo. So now I am a dev in and I am creating the same table with the same data that we have for our entities that we insert using Jakarta NoSQL. Now we have in Paris, in Ashburn, and we are creating in Sao Paulo. So just let me click, see what's happened. So we are waiting for the initialization to be complete. And execute the same query. So now it seems that it's complete. No. Okay, now it's complete. And now I can execute my queries. And of course, I can deploy a Kubernetes cluster in Sao Paulo, and I can deploy the application in the same way that we did. The only thing that I need to change is in my Apple YAML, instead to go to Paris, I will say that I want to go to Sao Paulo, okay? Then I will do, if you remember here, I have a read capacity of 10, a write capacity of 10. For this one, for Paris, I have 100, 1,000, 1,000. And here for this one, I want to have 10. Now imagine that I have more users in Sao Paulo, or I am not sure what are the users that I have in Sao Paulo. So I can say, okay, I am not able to say what is my read capacity, what is the number of read units per second that I am expecting. I want to say to Oracle, okay, we will do something similar to the scale. And in fact, I will say, I will choose a model on demand capacity. So meaning that I don't know what is the workload, and I want to just to be built for what I am using. So in this case, I will change on demand capacity. And by the way, I realized that I need more storage. So I will change the two things at the same time. So we will see what's happened. So here now we have read capacity. Sorry, we have for read capacity, we have on demand. It is not changing what I have in Paris. It is not changing what I have in Ashburn. But when I change the disk storage to 5, I will have the same disk storage in Paris. I will have the same disk storage in Ashburn. Of course, if I have to decide to create an index for performance, for example, I will create performance index. We choose my column content, and I can provide my field. So in this case, I forgot what we have here. For example, I will say that I want to create an index in the style. So I will say that it is string. Of course, I can use every single JSON path that I want to provide. If we have an array or if we have nested array, we can provide a path with the nested array. And I will add my index in the region of Ashburn. And you will see that the index will be created in all the regions in our replication. So here I create the performance. If I go here, it is updating. So I create my index also in Paris, and I create also my index in Sao Paulo. Okay. Again, for example, I can say I want to deploy my application in Ashburn. I want to deploy my application in Paris, and I want to deploy my application in Sao Paulo. Okay, but I want to access using, for example, ndcsdemo.com. So I want to use DNS, and I want to access directly to my application. So if you remember, here, just I will finish with this. When I configure, I have an external IP. So I will use the external IP of all of my Kubernetes cluster, all the public IP that I am providing. For example, if I'm using an API gateway, because in this case I have a private IP, but I can use an API gateway in order to say I want to have a public IP. And I can go, for example, in our case, we have a service in the networking that we call traffic management steering policy. So that is if you want to use our service, you can also use your DNS servers in order to do this. And we have the possibility to create what we call the traffic management steering policy. Okay. So in this case, I don't want to use a load balancer. I want to use what we call a geolocalization steering. So I will call this test Holiday, and I will create my pool. So I will start with Ashburn, and here I will add my IP, the IP of my load balancer for my deployment in Kubernetes. And then I will add another answer, for example, in this case, Sao Paulo, with another pool. I will add additional answer, and I will add Paris. Again, I will put here, I don't have the time, but I will put the IP for every single load balancer or for my API key. And then I will able to say, okay, if I am, for example, in South America, my priority is to go first to Sao Paulo. I think that we put Sao Paulo. Oh, sorry, I need an additional pool for Paris. Sorry. I need to delete this one. Okay. So for South America, I will say that I will go to Sao Paulo. If something goes wrong, I will go to Ashburn. Then I will add a new rule, and I will say, okay, if I am in North America, I will go to Ashburn first, and if something goes wrong, I will go to Paris. And then I can add an additional rule, and I say, when I am in Europe, I will go to Paris. If something goes wrong, I will go to Ashburn, and I will create my policy. Of course, if, for example, now I have customers also in Oceania, for example, I can say, I will add Oceania. I will create my pool for Oceania. Okay, so for example, in Melbourne, And I will deploy again. I will create another replica in my tables, and I will deploy in Melbourne. So just by clicking here, so I can say now I want to go to, for example, uh, Melbourne or Sydney. Okay. So I think that we are in time. So it finished my presentation, Octavio. Thank you.
Amazing. Thank you
Okay,
both.
nice.
Yes. Yes. Otavio, do you have any last words while I review any questions
No
that we
last
have in the
words. We don't have a question. So thank everybody. It was amazing here. And of course, if you do have a question later, like it's running, or you are watching later, or YouTube, so please put your question, mention us on Twitter, Think Java, and at Otavio Java.
I have a
Oh, sorry,
question
Think
for you,
NoSQL.
Octavio. I have a
chat?
question for you, Octavio. So we can deploy using another framework, for example, I don't know, Wi-Fi or something else, or just Celadon.
Yes, you can do using any framework that has support to Jakarta E. So Halidon, Whitefly, and right now even Quarkus. You can do
Pay,
it.
Payara, I saw that you have a meeting with
Yes,
Payara.
Payara as well.
Okay, very interesting.
Amazing. All right. So thank you both very, very much. Just a quick shout out. So there is two things that I wanted to bring to your attention. We're always looking to book more Jakarta Tech Talks throughout 2024. So we have half the calendar year booked, and we're looking for the second half. So I'm going to include a link that you can fill out the form to submit one of your talks. And then secondly, we have OCX, our event that is going to be taking place in October. It is the flagship event, also formerly known as EclipseCon. We are super excited to share this experience with all of you. So whenever you have a moment, I will link also the website to OCX, so you can go take a look at to what to expect for this event. So thank you again, everyone, and we will see you all very, very soon. Ciao for now.
Bye
Ciao.
bye.
Bye.